Okay, so let's say we have these two functions here, and g of x is square root of x plus 1. So where are you going to substitute that? So where do I plug in square root of x plus 1? But in which function, f or g? F, because it says f of this, right? The letter out front tells you which function to substitute it into. So you're going to plug that into x, but in the f of x equation. So you substitute that in, and you're going to square it. And what happens when you square a square root? It's just x plus 1. Okay, so here is the part that's tricky on this. If I asked you to find the domain of this, I would hope by now that you would understand that, Leslie, what kind of function is that? Linear. Okay, it's linear. And what is the domain? All real numbers. And so, if you were Leslie, you would think, all right, my answer is linear, domain's all real numbers, so I should be able to work any f of g of whatever problem that my heart desires, and I should be able to get an answer. So let's just try that out then. Let's do f of g of negative 10. I should be able to do that problem, shouldn't I? If the domain's all real numbers, shouldn't I be able to do that? Right? Should be, right? Okay, so let's do it. So let's do g of negative 10. So g of negative 10 means, where do I plug the negative 10 into? Where x is and which function? G, because it's g of negative 10, right? So g of negative 10 is square root negative 10 plus 1, which is square root of negative 9. And oh no, you get a real number, right? You can't take the square root of a negative number and get a real number. So this is no real solution. Okay then. So something went terribly wrong because I know that's linear. And I know that domain's all real numbers. So there's something I didn't consider. And here is the trick on f of g of x functions. And the trick is, you don't just look at the final answer. You do the domain. Alright. You have to look at a second thing. And the second thing is, right here, what you plugged in. You have to consider it as well. So make yourself a note. For f of g problems, you must check two things for domain. What those two things are, they are the final answer. And second, what you plugged in. This is one of the reasons why I've been emphasizing for the last couple of weeks about doing domain and range, because it shows up in so many places. Here's yet another place it shows up. So I have to know how to find the domain of square root of x plus 1. So right now, you only have 3 rules that y'all have to know. I mean, we'll be adding to these as the year goes on, but right now you've got 3. Okay? Well, number 1, if it's a square root, what do you do with what's inside? Greater than or equal to 0. That's rule number 1. Rule number 2 is if you have a fraction. You have a rational function or a fraction, the denominator is not equal to 0, right? And then most everything else is all real numbers. If it's a cube root or fifth root or absolute value, or if it's a polynomial function, those are all real numbers. do this, we get x is greater than or equal to negative 1. So what you have to do is you get to look at both the answers to get the domain. Alright, you have to look at both and you have to combine. So Chris, what's your question? No, I was just using, it could. That could be a problem. It could be, but these problems that we're going over right now, what it's going to say is, what is the domain of f, what's the domain of g, and then what's the domain of f of g. And what I'm trying to teach you is, to get the domain of f of g, you don't just look at the final answer. You have to look at what you plugged in. And I was using this to show you why you got to do that. So I didn't really have to do that, to be honest. Okay, so let's, because I've got a big mess here. Let's redo the problem. And let me show you now, if I was working it, this is the way you're supposed to do it. Okay? So here is the real work, if I was doing this. So this is how you're going to do like 63 or 65, those kinds of problems there. So if I have f of x plus x squared, g of x, square root of x minus 2. Here's what they're going to ask you to do in the book. They're going to say, okay, what is the domain of f? Okay, easy enough. What's the domain of that x squared? All real numbers, polynomial function. And they're going to say, okay, what's the domain of g? So after doing that, you said what's inside the square root, greater than or equal to 0. If x is greater than or equal to 2. You can write it that way, or we can think of what the graph would look like on the number line. Do it from 2 to infinity. Either answer is acceptable. So that's the review part of the problem. The new part, though, is they're going to say, what is the domain of f of g? Some of y'all probably say the fog problems. Okay, it's f of g problems, g of x. And so to do that, the first thing you do is you have to actually find f of g of x. And that's what I just worked out a second ago. We said this was g. Plug that into f. We got x minus 2 for the answer. So here's what we're learning. We're learning you have to do the domain of the answer. You have to examine that. And that is all real numbers. That's a linear function. But then you also have to examine the domain of what you plugged in. And the reason why is, think about when you do f of g of x. G of x is what you look at first, isn't it? So that's why you gotta look at its domain. And see, we've already done it. It was from 2 to infinity. So here's what the problem is telling you. If all I had to deal with was the final answer, yeah, I could use anything I wanted to. But this is telling me, hey, there's some numbers I can't use. So for my final answer then, if I've got to say, what is the domain of f of g, here's what you do. You say it's from 2 to infinity. It's kind of like this. Think of it this way. Alright? I'm giving you 2 clues on how much money Leslie has in her purse. Okay? I'm giving you 2 clues. Clue number 1 is, Leslie has up to $1 million in her purse right now. And then I'm going to tell you Leslie has up to $10 in her purse. So I'm telling you 2 pieces of information, right? So the first one doesn't matter, right? I told you she has up $10 million, and then I told you, well, she really only has up to $10. So even though I've told you those two pieces of information, and they both are true to some extent, because it gets kicked. This kicks it out. This is telling you it can't be negative. It can't be negative 10. It can't be 0. It can't be 1. It can't be 1.8. Right. So you have to look at both of them, and sometimes they both match up. I mean, this is the weird case. That's why I'm showing you this one first. But you have to consider both. That's right. It could be exactly, and I'm going to show you one where that's the case. So that's exactly right. Okay, let's do another one. So let's do one where it doesn't really matter. So let's do one where f of x is square root of x plus 6. And let's say g of x is x squared. Okay, notice how I did it different this time. This time, the square root's the f, g is the x squared. So here's how you would do the homework. Okay, so we would say, okay, what is the domain of f? So how do I do that? Greater than or equal to 0. Make that 6 over greater than or equal to negative 6. Okay, what's the domain of g? All real numbers. 1. Polynomial, right? All right. Okay, so that's the review. That's why we did all that stuff on the test yesterday about domain. Because you're going to use it in a whole bunch of places. Just to give you, for instance, in calculus, their test they took yesterday and today, domain was all over it because of the problems they're having to do in calculus. It's something different from what y'all would do. So this domain doesn't go away. This is one of the biggest things we'll do. All right, now we're going to do f of g. So f of g of x. G of x is this. So I'm going to do f of x squared. Alright, watch this carefully now, because I don't want you to mess this up. Now, x squared is what you're going to plug in, right? Which function are you going to plug that into? Yeah, because it's f of that, right? You're going to plug it in the f equation. So it's going to go right there where that x is in. So it's x squared plus 6. Alright, now we have to examine the domains of two things. First, yep, something else you can do. Because the only way you could do anything else to that is if it were multiplied, or if that would factor in some way. And it doesn't. It doesn't factor. You still couldn't do anything with it. The only way you could do something with it is if, like, if it ended up being x plus 6 quantity squared, then you could. Because there's could be two of them. Alright, so what's the domain of x squared? All real numbers. Alright, now the trick one here. Square root of x squared plus 6. Now we know that's a square root function. And we know we're supposed to set it greater than or equal to 0. Now, y'all had a problem like this on the calculator part of the test that a lot of y'all didn't do so hot on. But I can do this without a calculator now. I don't need a calculator to do that. Now, the ones in the test you needed to, because those are ones y'all don't know how to graph by hand. I know how to graph this one by hand. If I wanted to graph x squared plus 6, I know it's a parabola. 6. Okay, so now read the problem. It's all real numbers. The question is, when is x squared plus 6 bigger than 0? Here's 0. It's always, right? So that is an all real number. On your test yesterday, you had 1. Both of them were above it. One of them asked, when was it bigger than 0? And the other one said, when was it less than 0? And it was the same kind of graph as this. That is always above 0, right? When is it below 0? Never. So that was like no solution, empty set. Those weren't meant to be hard problems. But now we can do some of those without a calculator. So look at what you got. All real numbers, right? So all real numbers. So the domain of f of g is all real numbers. See, you're not always going to have something like that first problem I did. The first problem is the special case. A lot of times you're going to have this right here. End up the same answer. Sometimes they don't. Okay. Just make it a little bit more sense. Okay. Alright, let's just go through some. Okay, so let's do some of the weird cases then, because that's the ones that are going to maybe mess you up. Let's try one like this. Let's say f of x is 1 over x, and g of x is x plus 6. Okay, so tell me what's the domain of f. So x is not equal to 0, right? Now remember, the other way of writing that is that simply means there's a hole at 0, and it can be anything above 0 and anything below it, right? That's the union thing, right? Negative infinity to 0, 0 to infinity. Either answer is acceptable. So that's the domain of it. Alright, Leslie, what's the domain of G? Why? Linear. Okay, linear function. All real numbers is the domain. Okay. Alright. Now let's do the domain of f of g. Okay. So first, I've got to figure f of g of x out, right? So, I'll do f of g of x. G of x is x plus 6. And you're going to substitute x plus 6 into x, but you're going to do it in the f equation, which is this one. 1 over x plus 6. Okay, but here's one where the two things will be a little different, because for f right here, that thing right here, we're doing f of x plus 6, that's all real. So you do have to check it, but here it's not really an issue. That last thing is a big issue, right? We've already worked. We've got x plus 6 can't be 0. So x can't be negative 6. So now we got to put them together to get the final answer. So it's kind of like me doing this with Leslie. I'm going to make a new scenario. Let's say I made the comment that Leslie either has $1, $2, $3, $4, $5, or $1 million. That's my statement number 1. But then I say, well, Leslie doesn't have $1 million. Okay. I think that she did have 1, 2, 3, 4, 5, right? Okay. So what this is basically saying here is that this is saying, well, I can plug anything in here I want to, but you can't plug negative 6. So guess what the domain of the whole thing is? Everything but negative 6. So that's the answer. me two circles. A bracket? Oh, good question. Does it bracket means you're completed? Six means you're done. Alright. Now, we've got a couple of other odds and ends of problems that's on this homework that we need to talk about. Now, this next one has nothing to do with domain. This is how you're going to do 55 through 61. What they're in essence going to ask you to do is to decompose the function. That's what they're going to ask you to do. All right. What in the world does that mean? We're going to break it down. Exactly. That's exactly what you're going to do. So what you're going to do is we're going to do f of g of x backwards. We're going to decompose it. You're going to tell me what would f and g have to be so that if I do f of g of x, I end up getting this right here. Alright, so there's actually many answers to this. Alright, I'm going to give you the cheating answer. I don't want this in the homework, but this does work. Okay, I'm going to give you two cheating. I'm going to give you two of the cheating answers, and then I want you to see if you can figure out the good one. This is the one that makes you look smart. Okay, so here's the wimpy answer. Alright, so my wimpy answers, the wimpy answer is this. I'm going to say f of x is x, and g of x is 1 minus x quantity cubed. So here's how this is wimpy. So if those are my answers, here's what I should be able to do. I should be able to do f of g of x. Let's work it out. Alright, so I'm going to do f of 1 minus x cubed. And what am I going to do with that step? What am I going to do with 1 minus x quantity cubed then? Right, and that's just what it is. So, that does work. I mean, that is a correct answer, but that's really wimpy. No, I don't want that. That's your desperation answer. No, I want a good answer. Okay, here's the other wimpy one. Guess what the other wimpy one is? Backwards, yeah. Let that be 1 minus x cubed. Let that be x. Same deal if you did f of g of x. G of x is x. So this means I'm going to plug x, where x is at, into f, and then I just get this. So those are the wimpy answers. They are correct. They're not wrong. They're just really wimpy. So, well, this will be multiple choice on the test, so that won't even be an option. Okay, but still, we need to think though. Okay, so those two are true answers. They're not wrong. They're just kind of wimpy. So can you think of one that also works? It's not one of those two. Perfect. That's very good. Very good. Very good. Okay. So that's exactly what I want. What you do, you kind of think, the way I look at this is in math we call these the parent functions. See, that looks like x cubed, doesn't it? So x cubed is your f, and then what did they plug into x cubed? They plugged in 1 minus x. So, just to show you that works, if f of x is x cubed, and if I plug into it 1 minus x, if I do f of g of x, g of x is this, plug that into this right here, and you get it. Perfect. Good job. Most people don't get it, but that's good. But seriously, most people, there's usually a dead silence. That's good. That's good. All right, very good. I know that's usually what happens. Usually, so very good. Very good. Okay, let's try another one then, and see if you can figure this one out then. All right. Here, this one's I'm getting from the book. You don't have to necessarily write the number down, but square root of 9 minus x. Okay, so the answer is letting f be x or g be x. So I want a better answer. So what do you think? So think about, okay, what is the parent function? Square root of just x. And what am I plugging into square root of x? 9 minus x. Makes sense? That's the answer. That's right. So what do you think? Okay, okay. Well, no. Think of this the same way. Let's make sure you got it. Well, H is the. This is what's in the book. They're going to say, okay, there's the problem. You tell me what f and g is, so I can end up with that final answer. So the way I look at this, the parent function is, what does that kind of look like? 4 over x, right? And we know how to graph 1 over x, right? 4 over x isn't that much different. So the parent function would be 4 over x, and then what they plug into it? 5x plus 2 squared. However, can you give me another one that would be also just as good? 4 over x squared. And then what do they plug into x squared? 5x plus 2. Either of these answers would be, I don't consider either of those wimpy. Those aren't wimpy. Those are good ones. Okay. Is that making a little sense? So we're decomposing here. Alright, so then I've got one more thing. And don't try to draw this, but just watch, and we'll do this again tomorrow. But here is the other thing that's going to happen. Try this on the homework, but you're not going to have time to draw this. Let's say this is F. And let's say I tell you this is G. And let's say I say, what is F of G of 2? And I don't give you any, but I don't give you any equations. So now you have to know, really, what does G of 2 really mean? G of 2, what does that mean on a graph? No, it has nothing to do with transformations. It doesn't mean y equals 2, it means x is 2. So that's right here, right? So what's the answer for g of 2? That's what the 2 means, x is 2. What is 8? 0, because that is the Why? Remember, we talked about this a while back. 2 comma 0. And g of 2 equals 0 is the same thing. And then you would do f of 0, which is that right there. We'll do some more of that tomorrow.